So you were asked to show a diagram that demonstrates that this is equal to this. And so, as usual, I recommend you use the bar model. I'm going to cut it into 8 because the denominator of everything here is 8. So, if I cut this into 8 pieces, and here for 1/8, that's 1/8. I'm going to add 5/8, and 5/8 would look like this. 1, 2, 3, 4, 5. And as you can see clearly, the 1/8 plus the 5/8 makes 6/8, which if you are remembering about equivalent fractions in simplest form, you could see that you could divide the top and bottom, the numerator and denominator, by 2 and get 3/4. So this here is the same as 3/4, and you can see that because if you split this into quarters like this, in total 3 of those quarters have been shaded. So adding fractions seems to be quite easy, but don't be deceived, it can get a bit more tricky when the denominators are not the same. For example, let's say I had a third plus 2/9. So you think, oh great, bar, let's cut it into 3, and I'm going to shade one of them, that's a third. But now I've got a problem because I want 2/9, but these aren't ninths, these are thirds. So it doesn't work to add fractions if the denominators are different. Just like when we compared fractions, we had to make the denominators the same first so we could compare them. The same is true when you're adding or subtracting fractions. You have to have the denominators to be the same. Now let's have a look at the denominators. I've got 3 and I've got 9. Well, they can both go into 9. So if I multiply numerator and denominator of this by 3, I'd get 3/9. Now already it's beginning to look a bit messy, and that is not the best way to lay it out. So I'm going to show you underneath how I would like you to lay it out, and hopefully in your books you'll be doing this too. So this is what I had to do. Oh, that was not what I had to do. This is what I had to do. Now this is what you're changing. So times 3, and that becomes 3/9. So I'm writing out underneath, and you can clearly see what used to be in the third position is in the 3/9 position, and this hasn't changed at all, so I'm just going to put it exactly underneath what it was underneath before. So there we are, that's the same, that's the same. This is equivalent, but looks different. And now I can just simply add them. If I'd had it on my diagram, it would have been 3/9, add 2/9, well that's 5/9. In this case, you're just adding the numerator and keeping the denominator the same. Okay, you have a go at the examples now in the exercise. Remembering the key thing, as with comparing fractions, is you must make the denominators the same, and hopefully you're going to go for the lowest common multiple, remembering that you can do that by just going through your times tables. For example, if you are adding 2/5, 2/4 plus 4/6. Here you go through your 4s, you go through your 6s, and you'd see 12 is the first number they both go into, so you'd be wise to use 12 as your denominator, multiplying by 3 and multiplying by 2. Alright, have a go.